Thanks for watching my video. Today we are going to discuss about Dirichlet series of zeta function. So then is zeta of s is equal to 1 over s minus 1 sum from n equal to 1 to infinity n over n plus 1 to the power s minus n minus s upon n to the s. So this will be a converge when real part of s is greater than 0. So we are going to prove that the right hand side is equal to the left hand side. Okay, this is how I managed to prove this Dirichlet series of zeta function. So right hand side is 1 over s minus 1 sum from n equal to 1 to infinity n over n plus 1 to the s minus n minus s upon n s n to the power s. So now plugging the value of n, okay? When n is equal to 1, this will be 1 over 1 plus 1, which is 2 to the s, right? Minus 1 minus s upon 1 to the s, right? Then is for 1. When n is 2 plus, when n is 2, n will be 2, right? 2 upon 2 plus 1, which is 3 to the s minus 2 minus s upon 2 to the s, right? Now plugging for n equal to 3, 3 upon 4 to the s minus 3 minus s upon 3 to the s plus and so on. And this is up to 1, 2, 3 times, right? So if you plug for 4, 5, 6 and so on, you get like the series like this, okay? Now which is 1 over s minus 1. Now this is 2 to the s, here also 2 to the s, right? Now combining these two, meaning 1 minus 2 plus s, right? Minus minus plus, plus s upon 2 to the s minus 1 minus s upon 1 to the s plus 3 to the s is also there is 2, right? 2 minus 3 plus s upon 3 to the s plus, if you plug for n equal to 4 and so on, you get this one, 3 minus 4 plus s upon 4 to the s plus and so on, right? So which is 1 over s minus 1. So let me write this first. So taking minus common here, I mean s minus 1 upon 1 to the s plus, if you subtract this, s minus 1, right? 1 minus 2 is minus 1 upon 2 to the s plus, similarly here also s minus 2 minus 3 is minus 1, so s minus 1 upon 3 to the s plus, here also s minus 1 upon 4 to the s plus s minus 1 upon 5 to the s plus and so on. Now since s minus 1 is common in all these things, right? Taking out here common, s minus 1 upon s minus 1, 1 over 1 to the s plus 1 over 2 to the s plus 1 over 3 to the s plus 1 over 4 to the s plus 1 over 5 to the s plus and so on. These two can get cancelled, right? Cancel out. So what do we left? We left with the right hand side is 1 over 1 minus 1 to the s plus 1 over 2 to the s plus 1 over 3 to the s plus 1 over 4 to the s plus 1 over 5 to the s plus and so on. This is nothing but sum from n equal to 1 to infinity 1 over n to the s, right? So this is nothing but our zeta function, zeta of s, right? So we managed to prove that right hand side is equal to our left hand side. Therefore zeta of s is equal to 1 over s minus 1 sum from n equal to 1 to infinity n over n plus 1 to the s minus n minus s upon n to the s, such that for all real part of s is greater than 0. And this series of rearrangement of zeta function will work only for real part of s greater than 0. So this is how I managed to prove the Dirichlet series of zeta function.